Okay, welcome to Calculus video 5.3 number 1. 3 boxes here with lots of examples for you. Yay, examples. Okay, let's get right into exponents and log integrals. There are 2 basic rules. Here they are. Rule number 1, the integral of e to the x dx is nothing more than e to the x plus c. That's a simple exponent rule. This is awesome. This is really nice. The integral of e to the x dx is just e to the x, just like the derivative of e to the x is e to the x. That's the reason why. And similarly, the general exponent rule, so e to the u du is nothing more, or the integral of e to the u du is nothing more than e to the u plus c. So this stuff is really easy when you get down to it. So let me show you a couple of examples here of how this works. So number 1, here's a quick example. Let's go 2 e to the x dx. Well, we know from before that we can pull a constant through. So this is just 2 e to the x dx. And then the rule just says, well, the integral is just e to the x plus c. So this is just going to give me 2 times e to the x and then plus c. It's really that easy. That's really nice. Take a look at this one. About 2e to the 2x dx. So in this case, we can use a u substitution, and the u is generally going to be the exponent. So let's let u equal 2x. Then du is equal to 2 dx. And notice that you have a 2 dx sitting right there in your integral. So then I can rewrite this and say this is the same thing as e to the u, because u is 2x, and then du. This is wonderful because we know that e to the u du is nothing more than this just becomes e to the u plus c, where u is equal to what you made the substitution for. So that's just e to the 2x and then plus c. So very fun, very simple. These are kind of like my favorite integrals to do. Okay, yeah, that's it. So that's the first box. So there's your basic understanding here. Basic rules with some quick examples. Okay, box number 2 is more fun examples. Yes, more fun examples. Here we go. So A says the integral of 3e to the x dx. So we know that we can say that this is 3 times the integral of e to the x dx, which we've just now learned is 3e to the x plus c. Really nothing more to do there. This one's going to require a u substitution. So I'm going to say let's let u be 5x. Then du is 5 dx, and notice you have a 5 dx in your integrand sitting right there. So therefore, this is going to be 5 times, this is just going to be the integral of e to the u du, since a 5 dx is already there. Well, that's going to give me e to the 5x plus c. Couldn't be any easier than that. So pretty simple, straightforward examples. Let's do 2 more that are a little bit more complicated for you. Okay, let's try C. The integral of e to the x minus x dx. Well, don't forget that you can break up your integrals of subtraction as e to the x dx minus the integral of x dx. Well, this one we know is just going to be e to the x. And then this is going to be a regular old integral of x squared over 2 and then plus c. So collectively, that's my integral for that one. All right, let's do D, the integral of e to the 3x plus 1. So in this case, I'm going to go ahead and do a u substitution. I'm going to let u equal 3x plus 1. Therefore, du is going to be 3 dx. So notice I don't have a 3 in here, but if I do 1/3 du and then do 3 times dx and then 1/3 over here, notice that the 1/3s cancel out and you get the proper integrand. So then I can rewrite this as saying the integral, so 1/3 times the integral of e to the u du, which is just 1/3 e to the 3x plus 1 plus c, and you're in business. You're in business. Okay, hopefully this is sinking in a little bit. Let's try the last 2 examples in this box, and then we'll move on to something else, okay? So I've got the integral of 5x e to the negative x squared dx. So again, I'm going to do a u substitution right now. I'm going to say, let's let u equal a negative x squared. Okay? Then du is going to be negative 2x dx. Now, I have a 5x dx. So what I'm going to do is multiply both sides by a negative 5 halves. Multiply both sides by a negative 5 halves. And what that does for me is cancel out my 2's and cancel out my signs to give me the 5x dx that I'm looking for. So negative 5 halves du is the replacement that I can make. So this is going to give me negative 5 halves integral of e to the u du. All right? So moving forward, we just get negative 5 halves e to the negative x squared plus our constant c. And we're in business for that one as well. Okay, last one here, g. G says the integral of 4x e to the x squared. So again, I'm going to let u equal x squared. Then du is going to be 2x dx. But notice I have a 4x dx, so I'm going to multiply both sides by 2 to make this thing happen for myself. So 2 du is now equal to 4x dx, and that's exactly what I have in my integrand. So then I'm going to replace this as 2 times the integral of e to the u du, which is 2 e to the x squared plus c, and we are in business. Okay, hopefully this is starting to make some sense to you guys right here. Okay, last box is all about how you do a log rule for integration. And there's two rules. There's the simple one and then the general run. So if we have an integral of 1 over x dx, it's now equal to the natural log absolute value of x plus c. This is really important. This is why we write this as 1 over something. And we didn't introduce this rule before. And then we've got a 1 over u. Dx is the natural log of u plus c. That's our general log rule. So anytime you see that you have a fraction of 1 over something and you're integrating it, you're going to be introducing the natural log. Okay? So let me give you some quick examples here. So let's do the integral of 4 over x dx. So 4 over x dx. Okay? So if I want to integrate this, this is going to be 4 times the integral of 1 over x dx. And we just learned up here in our basic rule, anytime we have a 1 over x, we're going to introduce that natural log. So this is going to be 4 times the natural log absolute value of x plus c. So this is why that x can't be a negative 1 in our general power rule. Hopefully you made that connection, but if not, definitely wanted to point that out for you. Okay, what if I've got b over here? This one's a really good example, and I'm going to do it 2 different ways. This is the integral of 2x over x squared dx. So the first way, you can always simplify this and say this is the same thing as 2 over x dx, which is then 2 times the integral of 1 over x dx, which is just 2 times the natural log absolute value of x plus c. But let's say you didn't see that, and let's say you did a u substitution. Let's let u be equal to x squared, okay? Then du is equal to 2x dx. And notice you have a 2x dx right there. So this just becomes the integral of 1 over u du, which then becomes the natural log of x squared plus c. And don't forget your rules of exponents. In logs, this can come down front and give you 2 natural log x plus c, which is exactly what we got over there. So 2 different ways to do that one, which is kind of fun. Okay, a couple more examples here with you, just 2 more, and then we're done. So let's do this one. Let's integrate 1 over 2x minus 1 dx. So we can't write that with the power of negative 1. So instead we take a different approach and we say, let's let u be 2x minus 1. Then du is 2 dx. And I have a 1 dx, so I'm going to divide everything by 2 to make it match. So 1/2 du is equal to 1 dx, and that's what I want. So now I have the integral 1/2 the integral of 1 over u du, which is 1/2 the natural log of 2x minus 1 plus c. Beautiful. Okay, and the last one here, the integral of 3x over x squared plus 4. I can't rewrite this with a negative exponent because that exponent is a -1. And remember, in the general power rule, we're not allowed to have that, so we take a different approach. And we say u is equal to x squared plus 4. Therefore, du is 2x dx. And look what we have. We have a 3x dx. So what do you got to do to make that 2 into a 3? We're going to multiply both sides by 3/2. Multiply both sides by 3/2. Hopefully you see why, because the 2's cancel, and that leaves me with a 3x dx, which is what I have. So then this becomes 3/2 the integral of 1 over u du, which is kind of fun to say, which then becomes 3/2 the natural log of x squared plus a 4 plus c, and life is good. All right, you guys, there you go. First video lesson. Hopefully it makes sense to you, and we will practice more in class.